Today we're going to talk about volumes of various shapes. Some of them are labeled up here already. We're going to talk about cylinders, cones, spheres, cubes, prisms, and pyramids. Obviously that's not every three-dimensional shape that we can have. But we're going to start with the basics, the basic three-dimensional shapes. So first, a cylinder. The cylinder starts with a circle. When you're drawing it, you kind of make that an oval, because we're trying to get some perspective going on here. We extend some line downs and then draw the same oval on the bottom. Except usually we put dashed lines so that we can show that's behind what you're actually seeing. And we need to know what pieces of the cylinder should we use. So we need the radius labeled and the height labeled. The volume of the cylinder is based off the area of a circle. We know area of a circle is pi r squared. To get the volume, we put the height in the mix, so we would multiply by height. So volume of a cylinder is pi r squared h. Now, the only kind of semi-tricky thing that could happen is maybe they label the diameter instead of the radius. If they gave us the entire distance across, we know how diameter relates to radius. Radius is half the diameter, so we would just take the diameter and divide by 2 to get the radius, and then we would use the volume formula. All of these are usually trying to do real-world type problems, so they'll all have units of measurement. Maybe we had 8 inches for our radius and 12 inches for the height of the cylinder. So when we put our units, I use the word units because there's lots of things we could do. We could do inches or miles or meters, so on and so forth. So we need to make sure we put whatever units were given in the problem itself, cubed. Because we're multiplying 3 things together. We had a radius times a radius for radius squared times height. So unit times a unit times a unit is units cubed. A cone relates to a cylinder. Their formulas are very similar, and they found the formula for a cone by first studying a cylinder. So a cone, the base is the same as the cylinder. It's made by a circle. We would again need our radius labeled. And then our height has to be on the inside of the shape. Usually they show that it's been placed at a 90-degree angle. And a cone, if you took a cylinder and shaved it down, you could make a cone. And you'd have to shave off 2/3 of the cylinder. So we end up with the volume of a cone being 1/3 times pi times r squared times h. So most of the formula is the same. Pi r squared h is in both of these. The cone just is 1/3 the size of a cylinder. Next we have a sphere and a cube. So a sphere is a 3-dimensional circle, basically. I usually start by drawing a circle, and then you kind of draw an oval in the middle. And again, give it the 3-dimensional feel, even though we're drawing on a 2-dimensional surface. We want to try and make it 3-dimensional as much as possible. And with a sphere, all we really need is the radius. Again, they could give us diameter and we'd have to divide by 2. Or they could give us just the radius. It goes from the center to any point on the outside. So they could draw the radius in a whole bunch of different directions. They could draw the radius going this way. They could draw it going straight across. It can be drawn in a whole bunch of different areas. It doesn't have to be the way I pointed it. And the volume of a sphere would be 4/3 pi r cubed. Again, with all these formulas, you'll need to put the units, so units cubed would be at the end. If we had measured this in kilometers, we would put kilometers cubed at the end. A cube is a certain type of rectangular prism. It's made up of squares. So we start with our square first. Now, we could call this base times height, we could call it length times width to get the area of this square. I want to try and keep things all the same, so I'm going to use length times width for the outside edges of our square. Then we have to extend it back. When we extend our lines back to make, again, the three-dimensional shape, I'm going to call that line that's extending it back the height. Again, we could draw our lines on the inside. We usually put dashed to indicate they're behind. You can't actually see them. Now, a cube, all three sides are the same. So I don't have to label them differently. I could label it, usually we use like S for side. So I could write this as length times width times height, or I could say side times side times side, which is side is cubed. So that would be our volume formula for a cube. Now on the assignment, they sometimes label some extra pieces. They like labeling the ones that are kind of across from each other. So this bottom line was labeled W. They would repeat it. This would be extra. We would just not use it at all. Or the left side, they labeled length. Sometimes they like to repeat that on the right. Again, that's just extra. I'm not sure why they chose to label it that way. It's just the software I used to make your worksheet. That's that. So you should know before you start in on your assignment tomorrow. A cube was a special kind of rectangular prism when all three sides were the same. A rectangular prism, the sides won't be the same. But just like the cube, we started with a square. A rectangular prism, we'd start with a rectangle, still labeled length and width. I'm trying to keep it the same way of labeling it. And we'd still extend a line back that we are calling the height. Now this time I couldn't replace it with another letter. I can't say these sides are all the same. They're different. So the volume of a rectangular prism is first based off the area of the shape we're using. We started with a rectangle. The area of that rectangle is length times width. Just like how the cylinder, we started with the area of a circle. Then we multiply by that third dimension we added in. So volume of a rectangular prism is length times width times height. But in general, if we want to find any prism's volume formula, volume of any prism is the base area times the height. So if we want to find the volume of our triangular prism next, we need to know the area of a triangle. The triangle is the base of our prism. So let's draw it first and then discuss the formula. A triangular prism, we're sticking with just right triangles. We're going to draw a right triangle. Again, I'm going to label it the same as how we've labeled our other things. So since we labeled the squares length times width, we're going to label this length times width again. Normally we label a triangle base times height, but then we'd have height repeated, so I chose to just keep it the same as we've been labeling our rectangles. And then we have a line extending it out that we would call our height. So there is our rectangular prism. Again, we want the base area, so we have to think about what is the area of a triangle. Well, we know a rectangle is length times width. And if we cut a rectangle in half on the diagonal, we'd make a triangle. So we have 1/2 length times width. That's the base area of a triangle, but then we still have to multiply by height to get that third dimension. So there's our volume for a triangular prism. Now in both of these, again, the worksheet's going to have some extra information. It's going to repeat the W and the L on the prism, and it's going to give you the hypotenuse length on the triangular prism. But again, that's not necessary. It's extra information that won't help us find the volume. So we always remember to cross out the hypotenuse. Remember, hypotenuse is across from the right angle. Or on the rectangular prism, we cross out one of the numbers from our repeats. Our last two shapes today is a rectangular pyramid and a triangular pyramid. So they're similar to prisms in that they start with a certain base shape. A rectangular pyramid will start with a rectangle, just like a rectangular prism started with a rectangle. So it's going to start with a rectangle. This time we kind of want to tilt our rectangle as we draw it. Oh, and I should have made the back line dashed. I always forget that. Sorry, it takes a second to erase. So we should dash the back line. This line is actually going to be behind our main picture. And then I pick a point kind of in the middle, but up above my shape. And we just connect the corners of our rectangle to that shape. Now there's a very famous example of rectangular pyramids. The Egyptian pyramids were all rectangular. Well, as far as I know, I should look it up, but I'm not pretty sure they were all rectangular. That's what I remember them being, rectangular pyramids. So it's been a shape that's been used in real life. Again, we need things labeled, so I'm going to keep it same. I'm going to put the left side as length, bottom as width. We need a height. That goes from the top center to the middle of the rectangle. And again, they'll label that it came down at a 90-degree angle. So that's our height. Now when we did a cone was like taking a cylinder and shaving off part of it. Well, a rectangular pyramid is like taking a rectangular prism and shaving off part of it. So it's the same idea. It's going to be 1/3 times the volume of the prism. And that's going to be the same for all of our pyramids. So for a rectangular pyramid specifically, it would be 1/3 times the volume of a rectangular prism. Well, length times width times height was our volume of a rectangular prism. So pyramid is 1/3 times the volume of the prism that goes with it. So we would do the same thing for a triangular pyramid. We can get the formula without even drawing the shape. With a triangular pyramid, we would know the volume is 1/3 times the volume of a triangular prism. But let's draw a shape for our triangular pyramid so you know what it will look like. Instead of starting with a rectangle as the base, we start with a triangle as the base. And we do need to dash those lines. Then we pick a point up above, again kind of in the center. So we still need length and width. Length is kind of hard to see. Kind of got covered by the front line, but it was our first dashed line we had there. Width is also one of our dashed lines. And then height, we still need to draw a point from the top of our pyramid. Should have also drawn that dashed. Top of our pyramid to the center at a right angle. There is our height. Now again, it may give you some extra information on this picture. It will give you the hypotenuse as extra. The hypotenuse is across from the right angle that's on the base of the triangle, not the right angle inside the shape. So not the right angle with the height, the right angle on the base shape that's a triangle. So again, we said it would be 1/3 times the volume of the prism. So 1/3 times 1/2 times length times width times height. Well, we don't want to work with two fractions every time, so we're going to simplify it. So the volume for a rectangular pyramid comes out to be 1/6 times length times width times height. So we're just going to do two examples that show some of those tricky things that can happen. Not even especially that tricky, but trickier than just plugging the numbers into the formula. So we have two examples, and then we'll be done with this. So example 1 and example 2, you can see both right now. One is based off of a triangle. We have to decide, is that a triangular pyramid or is that a triangular prism? The second one's definitely a sphere. So in our first shape, we know the base shape is a triangle. The way we know this is a prism and not a pyramid is because it also has a rectangular shape involved in the picture. When you extend your prisms, you end up with some rectangular pieces. Those are called the faces of the shape. There are some rectangular faces and not just triangular faces. So we have to decide, we know, hey, this is a rectangular prism. We know the formula is 1/2 length times width times height. Well, there's 4 numbers there. One of those is extra, so we have to decide which one is extra. So think to yourself, which number is extra? When we talked on the last page, we said, oh, extra would be the hypotenuse of the triangle. Our triangle is there in blue. What number is the hypotenuse of the triangle? If you said 10, you would be correct. 10 is extra. We cross it out, we don't need it. Then we plug the rest into our formula. 1/2 times length. Length would be 8 times width would be 6 times 12 would be the height. Now if you have trouble deciding which one's length and which one's width, it doesn't actually matter. When we're multiplying 3 numbers together, order doesn't matter. If I multiply 8 times 6 times 12, I get the same answer as if I multiply 6 times 8 times 12. Now we go plug this into a calculator. 1/2, which you would just enter in as 1 divided by 2, times 8 times 6 times 12. We get 288 kilometers cubed. Remember, we need to put our units. If I wrote in 8 kilometers, which you don't have to write on the assignment, this is just to show you where we're getting the kilometers cubed, times 6 kilometers times 12 kilometers. Well, 8 times 6 times 12 gave us the 288. Kilometer times kilometer times kilometer. There's 3 of those, so it's kilometers cubed. And 1/2 didn't have units on it because it was part of the formula, not part of the picture. So 288 kilometers cubed is our answer. And the bottom part was just to show you where we're getting the kilometers cubed. Example 2 is our sphere. Again, it's only a little bit tricky. They gave you the diameter instead of the radius. We discussed, well, how do we find diameter? Or sorry, how do we find radius from diameter? We take that number and divide it by 2. We get the radius. Now we just go plug it into the formula. Formula for a sphere is 4/3 times pi times r to the third times 6 to the third. Again, we can just plug this into our calculator. I do want you to get the decimal this time. We've practiced sometimes leaving pi there as part of our answer. This time I want you to get the decimal. I put multiplication around the pi on purpose. Some calculators you don't need to hit the times button and it'll be fine. But if you have like an iPod or an iPhone, you have to hit the times button before and after the pi to get the correct answer. So we get 904, I want you to go to 1. Okay, so it paused for a second. I'm not sure exactly what I said before it paused, so I may be repeating some. So in our calculator, to get 6 to the third, we have a couple of options. Some calculators have this caret symbol that you have to plug in. Some calculators just have an x cubed. And some calculators have an x to the y button that you'd have to hit. So there's a couple of options. It depends on what calculator you're using. So I will see you guys tomorrow. That was our last new topic of the entire year.
Andrew Coleman, please report to
Sorry,
the
the bells
office.
rang.
Andrew
Ignore
Coleman,
all
to the
that extra
office.
stuff.